Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. The substrate is a tertiary alcohol with a chiral center bearing 4 different substituents CH3, CD3, pH, and O. It reacts with HBr, which is a substitution reaction, or replaced by Br. Moving on to the next step. Tertiary alcohols react with HBr via an SN1 mechanism. In SN1, the O is first protonated by HBr to form a good leaving group, water, which then departs to generate a planar, sp2 hybridized carbocation intermediate. Moving on to the next step. The tertiary carbocation formed is planar, trigonal planar. The 3 substituents, CH3, CD3, pH, lie in a plane and the empty p orbital is perpendicular to this plane. This means the carbocation has no defined stereochemistry at that center. And for the final step, the bromide nucleophile can attack the planar carbocation from either face, top or bottom, with approximately equal probability. This gives a roughly equal mixture of both enantiomers, R and S configurations, at the carbon-bearing Br. Because attack occurs from both faces with equal likelihood, racemization, loss of optical activity, production of a racemic mixture, occurs at the carbon undergoing substitution. A. Inversion requires SN2 mechanism with backside attack only. SN1 does not proceed with exclusive inversion. B. Retention would require a neighboring group participation or frontside attack preference, which is not the case here. D. The carbon is stereogenic. It bears 4 different groups, CH3, CD3, pH, and Br in the product, so this option is incorrect. Therefore, the correct answer is C. Therefore, the correct answer is option C.